Welcome everyone. This meetup is brought to you by the Hungarian Azure user group. My name is Zoltán Gombár and I'm one of the co-organizers of this meetup. Today we have a very interesting topic. As you know, in the Hungarian Azure user group, we are very famous of sharing new information, best practices, new features and solutions from Microsoft Azure. And today we will introduce you a showcase and walk you through the different stages of AI training and how to use it, demonstrating it with a toy train. And with that, I will give the word to Gábor Szabó, today's speaker. So Gábor, the stage is yours.
Welcome everybody. Let me start with a very interesting fact you might not know, that in the early or middle of 60s, the Gemini project was the first one which used a computer to navigate. This was an onboard computer and it had 7,000 operation per second performance. At that time, this was a huge step forward because now even the rockets could navigate themselves and they didn't need the assistance from the Earth. 10 years later, in the space shuttle program, which was a very famous one, they could almost 100% increase the performance of the same navigation system. Then, again, a little bit more than 10 years later, 15 years later, the first CPUs are coming to the market, which was available to the consumers. And even the old Intel 386 CPU had 11 million operations per second. That's already a huge improvement if we compare it to the Gemini project in the early days. Then again, 20 years later, the Sony PlayStation 3 had 150 gigaflops capacity. Just to be noted, I didn't find the proper data here to get the integer capacity, so I just found the float capacity, but it is still a huge improvement, especially if we consider the float performance is always smaller than the integer performance. Then, just few years back, AMD EPYC server CPU reached 187 tera operation per second. And just in this year, NVIDIA introduced the new AI-focused compute powerhouse, new server capacity with 10 petaflops, peta operations per second. That's a huge improvement if you consider that where we started 60 years ago with the Gemini and where we are nowadays with the NVIDIA. But why did I tell to you? You know that a few months ago, I participated on an AI-focused conference at the Technical University of Budapest, and there Professor Laszlo Mérő told that, yeah, come on guys, in the 80s we already had AI models, but we didn't have enough computing capacity there. But nowadays we have computers which are running 1 million times faster. And then the professor was right. So if you compare the early Intel CPUs and what kind of capacity do we have nowadays, then there is 1 million faster computers nowadays what we have in the 80s. But why does it matter for us in this topic today? Because this is also a direct consequence that why the AI solutions nowadays are so widely accepted, and we can see more and more solutions regarding the AI. And this is what we will check today. So I would like to talk to you about the Azure Cognitive Services, what kind of AI solutions Microsoft provide and how can we reach them. Then I also would like to show you that how the Azure Machine Learning solution works. And yeah, you saw several times in the post and then the invitation that I also built a little solution here in my flat, which uses these machine learning solutions, and it is called IoTrains. And we will go through on these steps at how it is built up. So let's jump into the middle and let's see that what are the Azure AI services, or in the old name, the cognitive services. First, I thought that I will list all the solutions what we know. And of course, one of the most famous one is the ChatGPT, what we can see nowadays everywhere. But yeah, if we see a little bit closer, then there are more than 20, 30 different AI solutions which are working out of the box, and they are offered by Microsoft. Actually, not just Microsoft offering these solutions or similar solutions, but Amazon and Google are offering this as well. But as I am focused on Azure, then I can show this to you. So instead of just telling one word about each solution, I just cherry-picked several ones what I thought that it might be interesting to talk about. Let's start with the cognitive search. The cognitive search is a solution which can dig into our documentations, our PDF files, our stored data, and can index the knowledge inside it. And actually, this is something what Microsoft just wired together with ChatGPT. So now ChatGPT is backed also with this cognitive search, with this knowledge mining solution. So the ChatGPT by native will be able to dig into the stored documentations and learn from this documentation and give back answers to the users. The next one is extract key phrases. There is a solution which can grab the most essence of a big wall of text. Just think about if we need to open a ticket to some kind of service and we write down that, yeah, my internet connection doesn't work. I see that it is breaking up continuously. Please help. And with an AI, we can analyze this text and we can grab the essential components like there is a problem with the internet, the connection is breaking up, and it can open a Jira ticket or a ServiceNow ticket or any kind of ticket to the service desk who can later on solve this issue. Decision making, anomaly detection on metrics. This is very close to the AI ops, which monitors continuously our environment and tries to predict if there is an oncoming failure or there are some issues with our deployment, and it can also react to these anomalies. So it can continuously monitor our infrastructure and can give triggers to any kind of actions, redeploy the application, increase the capacity, or whatever, or even it can tell us that we are under attack and we need to do some prevention steps. In the language area, you already likely know the ChatGPT, so I wouldn't spend time on that. But more interesting, the text-to-speech. And speech synchronizers or voice synchronizers is not a big thing nowadays. But the big thing here is that there is a solution if you make some voice samples, like what I did so far. I spoke approximately 5 minutes. It is more than enough to the AI to recognize the tone of my voice, and then I can generate text-to-speech, any kind of long speech with my voice. I don't need to read it and say it out, but this is something what we can. The AI can impersonate me, and it can use my voice to generate the speech. This is a very strange thing, and it opens a lot of questions about how ethical to use the AI and how to properly use it, but that's a different question. Don't go into it. Speech-to-speech audio translation. This is a fancy one which will break the barriers between the people that you're just holding the phone and you can talk to a Chinese with your native language, and then the phone can translate between two of you. If you see that as there are speech-to-text solutions, there are translation solutions, and text-to-speech, then it's pretty obvious that a speech-to-speech audio translation can happen immediately. And in the vision, there is a, let's say, almost infinite amount of topics what we can discuss about it. But instead of discussing, let me show this to you. Maybe it will be easier. If you have Azure subscription, then you can easily create a cognitive service, or you can use the Azure AI Studio. This is a framework where a lot of use cases are already brought together, and Microsoft provides easy to use API to try out their solution. Let's try out with the dense caption to images. Here you can see there are already some example images. So let me just click one of them. I love tractors, so it's an obvious choice. So the AI can analyze the picture, and it can tell us what can we see on the picture. It can identify a man riding a tractor. It can identify the tractor itself. It can identify the field. So it can give a full description about the picture. There is another solution, other AI solution, which can identify well-known landmarks. So if you show the Machu Picchu, then the AI can tell that, yeah, this is the Machu Picchu. So you find it. Let me show you another one, an easy one. Extract text from images. Yeah, this is a pretty easy. So the on-screen character recognition is with us a long time ago. But if you see that how precise it is, just see that here the notation is pretty faded, so it is not looking good. Even the servicing even worse because it uses gray, so you can barely see it. But the AI can pretty well determine all of them. Even vitamin A, 50%, even I hardly can read it, but the AI can read it pretty cool. And of course, this is not just the studio, so this is not just via a web interface or web UI where we can play, but they also have a REST API where we can send our pictures in, and then in a JSON format, we get back all the information what the AI find on the given pictures. There is another solution in the Visual Studio. It doesn't have, unfortunately, a test here, but there's a solution which finds the adult contents. So it can filter out the nudity, the violence. So a lot of things what we would like to prevent the kids are watching. So it is also good for website operators, which lets the users to upload any pictures publicly. Before you would publish the pictures, then you can say that, yeah, this is a safe picture, and yeah, this is something what you can upload to the internet. I also would like to show you one more in the video summary. Even with the video indexing, we can send in a video and we can ask what to do, summarize the video. And then the AI can watch the video and can write a proper description that a person is seen using in the server room. A worker is seen falling briefly on the floor. It's coming in the next video. Unattended backpack can be seen in the server room. So this is something what we can use for surveillance and proper detection what is happening. And this can be done real time as well. But of course, these services are running inside the Azure environment, but start to using them, it's pretty easy. You just need to register this cognitive service solution, and then you get an API, and then you can start using it via REST API. But you came here today for the little trains. Okay, the idea of the trains and the next step is that besides the cognitive services give a good overall overview, some out-of-the-box working solutions, but those solutions don't really work for all the use cases. So there are several customizable solutions what the customers would like to use. And there are these predefined solutions, these 20, almost 30 different solutions don't really give a final proper solution. And here comes into the picture the Azure AI. The Azure AI gives us an environment which let us build our own AI model. And that was the idea here with the little train as well. And this is something what I built, let's say, 1 year ago. A customer approached us that they are interested in Azure Arc and they are interested in the edge cloud solutions. And we were thinking about how to surprise the customer with some demonstrations about our capabilities. And this is what I would immediately just build it up. So I took the kids' toy train, put a camera on top of it, power bank, a Raspberry Pi, and the Wi-Fi module, and started to work it. But this was the first version. In the second version, what a surprise, my son just got a Lego train to Christmas. And then we used this Lego train because it is much more massive and we could hide the different components there. So what we have, that we have the little train itself. So this is a modified Shinkansen, the Japanese fast train. It almost goes with 320 kilometers per hour, but rather it is just millimeter per hour. We put the camera on top of it, which takes the pictures. This is a full HD camera. Then we have a very simple Raspberry Pi B1, so it doesn't have any processing power. So this is one of the weakest Raspberry what I used here. There is a Wi-Fi AC Wi-Fi stick. We needed a high-speed network connectivity to transfer the pictures as fast as possible to the server. And finally, there is a power bank which gives fuel to the Raspberry and the connected components. There is one purpose of this setup. The Raspberry just goes around in my living room and takes pictures as fast as it can and send it to the server. And there is Ted. Our task today is to find Ted and mark it. By the way, I thought that, okay, the first version of the IoTrains was a pretty ugly one. So I started to think about that, how can I make it a much proper one? So this is the V1.2 version where there is the small power bank, which powers an ESP32 CAN. Even such a small thing, ESP module can create pictures in every second and can upload the picture to the server as well. So even a very small microcontroller is enough just to collect the data. It's important to see that these are the data collectors, so they are not doing any processing on their own. And if you visit the link marked here in the bottom right side, then you can see a live demo. The train goes around in the living room and tries to identify the Lego figures. You can also see the confidence written on top of their little boxes. And yeah, of course, the model is also doing some mistakes. So it will identify some components which are not Lego figures, but you can also see that in those cases, the confidence is pretty low. It's more around 70%. I set the threshold to the confidence at 70%, which means that everything which is above, the AI thinks that it is a Lego figure, then it is marked, and everything above 70% is already masked, or this little frame is just put around it. Feel free to watch the demo. Hopefully you have the link. Okay, let's continue. How does it work? How it is built up? First of all, as I mentioned, there is the train which creates the pictures. And there is a computer which is just a single one-node computer, and I installed Kubernetes on top of it. Actually, this computer has a GPU which is needed to accelerate the model execution. I will talk a little bit about later. So the only thing what the train is doing, it saves the image as fast as it can to the computer's storage, internal storage, for additional later processing. The computer is connected to Azure. It is called Azure Arc, and I will talk about detailed a little bit later again. So this computer is connected to Azure, and inside the Azure, there is an Azure ML workspace. In the Azure ML workspace, I created a model which can recognize the Lego figures. So there is an AI model which can process images and do image detection, and it is primarily trained to recognize the little Lego figures. And then once this model is ready, then I push it down to the computer, back to my residence, so which is running here. And then I have a little script which is based on Bash and Python, which reads the images from the local drive, send it to the machine learning endpoint for evaluation, for scoring. And the machine learning will tell about the picture, where are the coordinates, where it finds Lego picture, a minifigure, and send it back to the script. Then the script will find the coordinates and will put a little box, a little mask around the Lego figures to the coordinates and saves it to the disk. Then there is a web page which exposes these pictures, and you can watch it on your own desktop. Originally, I planned to expose this server directly to you, but I just realized that if all of you connect to this service, then you will immediately exhaust my network connection. So rather than you are connecting directly to my computer, I save the pictures also synchronously to Azure, and there is just a static web page in Azure. But the service is available locally, and this is something that I can show to you as well. So here you can see there is a local IP address, and it has the same pictures. Yeah, in the background you can see my son as well. He is my little helper for today. Yeah, he got to the task that he needs to play with the Legos. Yeah, a hard help. Let's have a little bit closer look at how these components are built up. There are two big components here. The one is the Azure Machine Learning environment, and the other one is the Azure Arc. Let's start with the Azure Machine Learning. Once we create an Azure Machine Learning workspace, it is actually a collector, a framework, which collects a lot of different components from the Azure services which are necessary to build a machine learning or an AI model. So once we create a machine learning workspace, it's just a very short single command, create Azure Machine Learning, Azure ML workspace. We just execute this command, and immediately a key vault will be created, a storage account will be created, which are necessary to store our secrets and to store our metadata. Then Also, some logging solutions are necessary for the Azure ML as well, because we will use this for training our models. We are using it for deploying our models. So we need an application inside a log analytics workspace. In the background, there will be a Cosmos DB and the cognitive search, which are storing the logs and the results coming from the running models. And the cognitive search is used to evaluate these metrics as well. Then we need some data storage for the additional data, like a data lake, or we can use a storage account as well. By the way, in this example, I used a simple storage account just to upload my files. So this will be used for the input data where we will store our pictures. Then there will be a container registry, because once this whole environment created a model for us based on the input data, it will generate an AI model, and it can build a container which can use this model and which can be deployed anywhere on top of Kubernetes cluster. And of course, we will need some computing capacity as well. We can use a compute instance, which is a single virtual machine, or we can use a computer cluster, which is a VM scale set. Or even we can use a Kubernetes cluster to deploy these models or to use for training the models as well. And once we are ready, then we will use an Arc-enabled service on the on-premise side, which runs the Azure ML extension. I know that it is a pretty complex thing, but the good news is that Microsoft hides most of this complexity, and we get a pretty neat environment in the Azure ML Studio where we can do these training activities. And that's why I suggest to start with this one if you would like to experiment with the AI, because it leads you. You don't need to have Python skills. You don't need to understand how the little neurons are resonating inside the AI model. But with some next finish, you can build up your own AI model. So you have a good entry point into the AI ML world, and you can start experimenting with it. Okay, let's see that what is the process of building our own machine learning story. Then the first thing is that collecting some data. In our case, we need to create some pictures because we are doing some object detection model. But there are some very important rules. You need to have tons of pictures. In my case, I have more than 600 pictures or annotations for the Lego figures, because you need to show to the model that how a Lego figure looks like. And more to show that, yeah, this is a Lego guy, this is a Lego guy, this is a Lego guy. More you show, the model will believe it much more confidence. It is also important to have a diversity. Actually, my model, what I trained, it hardly recognizes the Indian figures, because in my set, I have only just 2 of these guys, and I have hundreds of different other one with the blue. And the very typical guys, like Emmet, the model can recognize it with more than 98% confidence, because Emmet is such a standard guy that even the AI model can recognize it easily. And even I created a dedicated role to Darth Vader, because I thought that recognizing the Darth Vader is fun. But I just created, I don't know, 10 pictures about Darth Vader. And I intentionally marked that, yeah, this is a Lego figure. This is a Lego figure. This is also a Lego figure, but this is Darth Vader. Learn it, because it will be so much fun in the demo that I am showing that, yeah, my model also can recognize the Darth Vader. But the thing is that from the 600 pictures, I had only just 10 pictures focusing on the Darth Vader, and hence it wasn't enough for the model to learn that who is Darth Vader. So it is very important to have as different diverse data as you have. In the AI, it is called that the model is biased. Biased because it just learns that these are the Lego figures and has only just few idea that this is also a Lego figure. Because what can an AI model do? Just think about an AI model that can recognize objects, but it has no clue about what are the objects. In one of my blog posts, I am also writing down, if you don't know that what is smorgos means, then you have no idea. If I show you some pictures that what is smorgos, then you have a better and better understanding, but you still don't know what is smorgos. And by the way, smorgos is sandwich in Swedish. So if you see some sandwiches, then you can have a guess that, okay, the smorgos is something like 2 breads with some meat between them. And yeah, we also know it is a sandwich, but wait, is it also tomato in it? Because I saw pictures that there are tomato in it. Yes, smorgasbord also includes tomato as well. So you need to have more data, more diverse data for the training as well. And if you have a good incoming set, then it will be more good for your model as well. You might also heard about that this racism question comes back time to time when we read in the news that even some large language models, GPT, early GPT variant, they were also racist. Not the model itself racist, but the training, the input can make it racist. Matching the training and scoring quality. When I first made my first model, I made a big mistake, and I created pictures with my phone and with my proper camera. And later on, for the scoring, for the evaluation, I used much less quality camera, like a full HD camera, USB camera. The quality difference was huge between the two, and the AI model was learned that, yeah, this is the Lego figure which has such details, like it has an internal shirt as well. It has a little label on the leg. But of course, you cannot see these details if you have a full HD camera. Look at this. No such details. So it is very important that your input data shall match or shall be pretty close to those quality what you will use for the scoring as well. For the next steps, let me just show it to you. It will be much easier. Here is the machine learning studio. Again, we get a nice UI, and some use cases are already prepared. So if you wish, then we can start experimenting with those ones. But in this case, we use the Azure ML to build our own model. For that, first of all, we have to have our data set. So for that, I created the pictures. I uploaded it to a storage account. And here you can see that there are the pictures. And here you will see a preview. So this is nothing special. I just uploaded the picture. Yeah, this is what I told to you, that there were pictures what I made with the proper camera, and it had a very good quality, because I thought that if I make a good quality pictures from different angles, then it will be good. But in fact, it didn't. And then I created some pictures, live footage pictures with the toy train itself. So I just let it going around in the living room, and it created some pictures. I selected several ones, and then on those pictures, I just marked for the data. So once we have our data set, then we also need to show to the AI model that what is a Lego figure. Because if you just give the pictures, then it will have no clue that what is a Lego figure. And this is called data labeling or data annotation. It means that I open my data set, and then I need to do the labeling. The labeling means that I have to tell to the trainer that, yeah, this is a minifigure. This is also a minifigure. That one is also a minifigure. Yeah, this guy is also a minifigure. And submit. You need to show to the model that these are the minifigures. This is how we prepare the data. And yeah, this is damn boring task. So if you have a kid, like I have, then you can ask them for some extra credits to do the labeling, and they will be more than happy to do it. Once we finish with the labeling, here you can see that I have almost 600 labeled minifigures. Then we have annotated data. So now we have the pictures and we mark them, yeah, these are the Lego guys. There is an awesome feature here in the Azure ML, which is called automated machine learning. Automated machine learning means that we can feed in our data into this model generator. We select our data set. Here are the already labeled annotated minifigures. We would like to do an object detection training. We would like to train our model based on the label. And here we can select that we are using a compute cluster. I intentionally created a virtual machine scale set inside Azure. So here the idea was that I can train the model inside the Azure, and once the model is ready, then I can push it down to my local computer to run it. So there is some local data center capacity what I will use for the training. Then I can set that what kind of model I would like to use. One of the most favorite one or most famous one, the YOLO V5 or the ResNet, different kind of models. So I told to the automated ML that, yeah, try with the YOLO and try with the ResNet as well. ResNet 34 and the ResNet 50. These are just a different size of the models. Then during the training, it will try to create a model with YOLO, ResNet, whatever, and it will compare the result, how well it can train the model. But again, the model itself is just ready for recognized objects, and it has tons of parameters. Even an empty model has tons of parameters what we can fine tune, like what kind of optimizers we would like to use inside the ResNet, because there are different kind of solutions there as well. What the minimum scaling, picture scales, what we would like to set. What shall be the learning rates? And what we can do here is that we are setting up the corner cases. These are called hyperparameters. And then the Azure AI will automatically pick a random value inside these ranges and will try to teach the model, train the model with those randomly picked parameters. And then once the training is finished, then it will evaluate the model and will check that how does it perform. And now I cancel this because I already run this. Actually, it is approximately a 2-hour process. Here you can see that this training took 2 hours for me, and I used 3 virtual machines for this training method. Let me show you what happens. This is a try and error method. So it picks a parameter set, and with that parameter set, it tries to teach the model. And it checks that how it progresses. If it progresses in the positive way, then it continues teaching the model. But once it drops the performance, then it stops the training and says that, okay, this is not a good parameter set. Then it tries out another parameter set. If the next parameter set gives a better result, then it knows that, okay, it moved into the right direction with setting the parameters. And it repeats time to time, and it continuously checks that which parameter set is the best, and then it tries to reach the highest scoring matrix, which is 100%. Of course, if a model can recognize the Lego figures with 100%, then it's something is wrong, because we cannot be sure that it always 100% confidence, but on 95% confidence, what I could reach here, it's a pretty good one. Even it's too high, actually. So what the automated ML tries, here you can see that it tried out 30 different configurations, and it picks the best from this configuration. And then if we have these metrics, then it will output the models. We get these models. Here you can see how good does it work, what is the confidence it performed. So this is the performance measurement value, and we can see that there are the different models. And of course, those models which didn't cut the threshold, then those are not listed here because those are anyway trash. But these models are pretty fine. So of course, we would like to select the fastest one. But if you see that there is a model which is a ResNet 50, and there is a model which is a ResNet 35, they have almost the same performance. But if you need to make a decision, for example, here between the 50 and the 34, and you see that the confidence is very similar, or the performance of the model is very similar, then you also need to know that you need to go with the lighter one. So it doesn't make sense to run a stronger model which requires more memory, more CPU power if it performs more or less the same way than lighter version. So in this list, it looks that 0.98 is this model. So we can just simply select it, go to the deploy, real-time endpoint deployment. And here I will show you that I already selected one model. Here is the one. And here if I deploy it, then I can select that I would like to deploy this to a Kubernetes cluster. And I already registered my local machine to this Azure ML workspace environment. So I can select my Kubernetes cluster, and with the next finish, I can just say that, yeah, I would like to deploy this. Default parameters are nice. For a scoring script, I need to select a very small Python script, which will call the model. I do it. I created an environment. An environment means that what shall be included into the Docker container, which will be used to run our model. we can also select that if we would like to scale it automatically or not. As I have just one computer with a GPU accelerator, I cannot scale it, and even the instance shall go to 1. And the instance type shall be a CUDA instance type. So my cluster will know that this model requires a CUDA acceleration, and it shall book a GPU for it. Then I also can tell it what shall be the traffic percentage to send it to this model. Because on my computer, a load balancer and Envoy proxy is also running. So you can deploy multiple models if you would like to test that, especially in a production environment. Just start to think a little bit bigger than just a toy train here. If you have a production environment where you have, let's say, 10 servers with different kind of models, then you also would like to try out that how the new model performs and how does it work. So you can set the percentage what you would like to send to this model. And again, next, finish and create. I don't create it because I already done it, but the deployment doesn't take more than, let's say, 5 minutes. And from the 5 minutes, the biggest part is to download the image. And here is our little endpoint, which is already running. And this is used to recognize the Lego figure. So this is currently used in live on the system. And it is a very simple one. I can show this to you. It gets internal IP address. This is coming from my system. So Kubernetes will allocate this IP address. And the Azure ML also aware about that the service got this internal IP address. So it will give us this scoring endpoint, the REST API endpoint. And there are some authentication keys as well, what we can put into the header. And here there are some prepared Python, C# and Ruby script are prepared to call this model and send in our pictures. So actually this Azure ML gives everything into our hand to execute this model. I also have a little Python script, very similar. I use this example here, which reads the picture from the disk and sends it to this endpoint directly for the scoring, for inferencing. And that's it. The final step is just running this Python script, sending in, and we can see how does it work. And yeah, this is what you can see in the demo as well. So it's actively going around and it can interfere. Okay, one thing here that I didn't optimize this model too much. So the scoring itself takes approximately 800 milliseconds. And actually this is something what we can get as a monitoring feedback as well. So we can see some metrics, how our model is evaluating. And here you can see that the evaluation takes 800, around 900 milliseconds. We can also see from the logs what is happening there. We can see that new scoring request is coming in every time and it is logged. So the good news and good thing here is that we can run everything locally on the on-premise data center, but we can have the full management inside the Azure environment. So if I am an infrastructure operator for a big customer who has, let's say, 50 different edge cloud sites, then it is a very useful tool to have a central monitoring of this machine learning model working, how those are performing. And you can also check if the resources are performing well, so there is no any strange thing going on one of the sites. So you have a central visibility of all the sites. So finally, we have our model, but we also need to run this. And how does this model goes to our computer? And here comes into the picture the Azure Arc. So first of all, we need a Kubernetes cluster. Once we have it, then there is a solution inside Azure which is called Arc, Arc Connected Kubernetes Cluster, which means that we can deploy a set of agents into the Kubernetes cluster, and then it will be connected to the Azure environment. So we will see our Kubernetes cluster running inside the Arc, and we can gather information. Once we connected our cluster to the environment, then we can use the Arc extensions, what we can deploy to the cluster. The extensions are a bootstrap environment. They create a bootstrap environment on our cluster to host Azure resources. 2-3 years ago, even earlier, the Microsoft guys started to containerize all their services because a containerized service is scaling much faster in a public cloud environment, and it gives much more flexibility to us as well. And they decided to start this containerization. And then came the great idea that, oh, guys, we containerized our services. But as they are containerized, one of the biggest advantages of the containerization is the portability. So those can run everywhere. So the Microsoft guide created this Arc-enabled services, which means that we can make our notebook or server or desktop PC or whatever extension of the Azure environment, and we can deploy Azure services on top of it. And this gives these extensions to us that if we deploy this extension, then our server will be capable to host an Azure App Service. It will be able to run Azure Event Grid, Azure ML, what I'm using currently, Azure API management, Azure vFunctions, Azure Logical Apps. And I forgot to mention here the Azure Postgre or the Azure SQL database. So we can host Azure services on top of our computer. The biggest advantage here is that there are still some workloads which cannot move to the cloud, but we still can bring the cloud services to these services. So we can have the central management of these services, but running them on the on-premise environment. Let me show this to you. How does it look like? So in the Azure environment, if I go to the portal, here you can see the different kind of resources. Here's the machine learning workspace, what I mentioned to you, and the tons of other services are part of those what Azure automatically creates for us in the background. So we don't need to take care about it. What I created that here you can see the Arc connected Kubernetes cluster. Then you will see that we get a very similar interface like we get for the Azure Kubernetes services, the native Kubernetes service coming from Microsoft. And we can see very similar outputs as well. We can see that what is the Kubernetes version, what I'm running, what are the capacity of the cluster. Yeah, this is a one node cluster, but still you can see the capacities. You can see the different capabilities. But what is more important and more interesting to us, these are the extensions. Here I already deployed 3 extensions. The one is the Azure ML extension, because this is something what we need to attach to the machine learning studio, ML studio. There is the app service extension, which makes us capable to run the application services, Azure application services, and the Azure monitor, because that will collect the logs centrally in the Azure environment. But here are the other extensions as well. Once you deploy the extension, then you can use this cluster to deploy Azure services on top of it. Let me just quickly show this to you. I go to the app services. As this cluster is also app service capable, then if I create an app service, let's call it test. It is already taken. Don't worry, that's not a problem. Go with Linux. In the region, here where you would select that in which region you would like to deploy, just scroll up to the top and there are the IoTrains. Here is our own cluster. And then with these steps, we can deploy this web application on our cluster. Centrally managed in the Azure portal, in the Azure data center, but everything is running on our cluster. And very similarly, it is also attached to our machine learning studio as well. So once the extension is installed, then it has the capability. And here you can see the registered Kubernetes cluster. And here you can also see that it is working and it can accept connections. Okay, and this is the picture of our solutions. So we talked about that what is running on the server, what is running in the Azure as well, and I walked you through the whole process. Nevertheless, it is a very complex one, and I know that it's hard to follow. So this was just a teaser that how you can do these deployments. And if you visit the guide on this left side or you read the QR code, then you will see some blog posts about the detailed technical descriptions how to do this deployment. What we discussed today. We discussed first the AI services. There are the native Azure AI services, what we can use. It's coming from Azure by default, so it's ready to work. I showed that what can we use local Kubernetes together with the Azure Arc. We can connect it to the Azure environment. We walked through that how an Azure ML can be used to train our own model and how can we leverage this capability. You could see some electronic stuff as well. It's also part of the project using Raspberry, ESP32, whatever. It's always fun, play with those. And there are some scripting aspects as well using Python, Bash, or JavaScript. Most important thing, try to think out of the box. This is one of the biggest takeaway here, that if you try to get familiar with a technology, don't just follow the documentations, but try to grab the essence and try to find that how you can make it much more fun. Because if you find a good use case, then you start to dig also deeper and deeper and try to figure it out that how it can perform better, what other capabilities does it have, and it gives a good motivation for the learning as well. So what I can suggest to you that take a very simple use case, what you like, and try to wire everything together and make a good solution. And as I mentioned, everything is documented there in the blog. Okay, and that was about the presentation. Let's see if we have some questions. Can this detect other objects or only Lego minifigures? As I mentioned, this is something what I trained with Lego figures, but you have an opportunity to do a labeling with multiple labels. So once you are doing the labeling, then you can say that this is a minifigure, this is an apple, this is a banana, this is a train, or whatever. So if you mark multiple different objects, then you can train your model to recognize different objects as well. Just remember what I mentioned with Darth Vader. You need to have the same amount of pictures with all of the objects as well. Otherwise, the other average guys will dominate your model. Is the demo cam 1 FPS or more? The camera can create pictures with 2 FPS, but the evaluation is done in 800 milliseconds. So yeah, let's say it is 1 FPS. Currently, nowadays, there is no such as a live camera evaluation, but even in a camera stream, it is cut up to 1 frames, and then each frame is evaluated independently. In this demo, I didn't have enough capacity to work with video streams and then disassembly, evaluate, and reassembly again. By the way, I can use this model for concurrent evaluations. So I think I have enough capacity to multiple frames parallel. And of course, there will be some delay, but I think the capacity will be there. Maybe this will be the next improvement. Can we use this model for autonomous train driving as well? Oh, yeah, I hope so. Actually, I have a Lego hat which can manage Lego motors. So this is what I tried out. I built it into the train, and with a Python script, I can manage it. But again, here the problem is still that we have this 1 frame per second, so there is 1 second delay. So my idea was that I recognize if something is on front of the train, and if there is a guy there, then I stop the train. But due to the 1 second latency, it is still too much for the driving. But I will give a try with lower resolutions, and with lower resolutions, the scoring is faster as well. So maybe that will be the solution. What size of machine do you need to run this setup? The smallest one is, let's say, 4 CPU and 16 gigabyte of memory, or it can work with 8 gigabyte memory as well. But for running the AI model, you need an NVIDIA GPU due to the CUDA acceleration. There are also models which can run on CPU, but it will take ages for inferencing, or at least, let's say, 5 seconds per picture. When the model is deployed on the node, are compressing the model by reducing the complexity, pruning quantization. Honestly, I didn't went such into the details how the model itself works. What I'm doing here is that I send in the JPEG, the 1280 multiplied 720 size pictures, and let it to the model. I tried different configurations for splitting up the picture to smaller chunks inside the model. So the model is capable for quantization, and it can do it, but I didn't check the parameterization if it is doing in the real time. So the model is capable, but honestly, I don't know if I am using. I didn't check it yet. You can reach me on the link. So if you are interested in such similar demos, just feel free to follow me or check back time to time to the blog career as well. I also would like to say many thanks to the Deutsche Telekom team because they sponsored and put a lot of efforts into this meetup as well. So big kudos to that team who organized it and make it happen. Thank you very much. And with that, I give back the word to Zoltan.
Thank you for the interesting questions. I think it was a very fun and in the same time very insightful presentation. So thank you, Gábor, for showing this to us. I think we've learned a lot. Our YouTube channel is called Clouders Club. So feel free to subscribe so you get notifications for other cloud themed videos as well. The same goes for the Hungarian Azure user community on meetup.com. If you are not a member yet, I would suggest you to join us and get the email notifications about the future events. Thank you all again for coming, and see you next time for the upcoming event. Thank you.
Thank you very much. Bye-bye.